Learning never stops, and it is up for grabs. Good day, learners! Join me as I guide you every step of the way in learning mathematics the fun way. Welcome to Grade 8. Our first topic for this school year is factoring polynomials. This is anchored from the most essential learning competencies for Grade 8. The learning competency factors completely different types of polynomials. Polynomials with common monomial factors, difference of two squares, and the sum and difference of two cubes. M8 AL dash Roman numeral 1A dash B dash 1. The first type of factoring that we will discuss is factoring polynomials with common monomial factor. We will start with this topic using the algebra tile. In this method, we will be using a small square tile to represent ones, a rectangular tile to represent x, and a big square tile to represent x squared. The dimensions of the big square tile are x and x, and its area is x squared. The dimensions of the rectangular tile are x and 1, and its area is x, while the dimension of the small square tile are 1 and 1, and its area is 1. Let's try to apply it with a polynomial expression. Example: 3x squared plus 6x. 3x squared will be represented with 3 big x squared tiles, and 6x will be represented with 6x tiles. Arrange the tiles to form a rectangle or a square. The rectangle which was formed has a dimension of 3 x's or 3x. And the other side has an x and 2 ones, or x plus 2. Hence, the factors of 3x squared plus 6x are 3x times the quantity of x plus 2. Example number 2. 7x plus 14. 7x is represented with 7x tiles, and 14 is represented with 14 1 tiles. And arrange these tiles to form a rectangle. The rectangle which was formed has a dimension of 7 ones, or 7, and the other side has 1x and 2 ones, or x plus 2. The factors of 7x plus 14 is equal to 7 times the quantity of x plus 2. What then is factoring? Factoring a polynomial is rewriting a polynomial as a product of 2 or more polynomials. For example, x squared plus 5x. The factors are x times the quantity of x plus 5. For 3x squared plus 9x, the factors are 3x times the quantity of x plus 3. And for 4x squared plus 8x, the factors are 4x times the quantity of x plus 2. The left side of the equations are the products, and the right side of the equations are the factors. For us to factor polynomials with common monomial factor, it is important for us to review the concept about greatest common factor, or GCF. Take for example, x squared plus 5x. Factor x squared and 5x using prime factorization. The prime factors of x squared are x times x, and the prime factors of 5x are 5 times x. Align the common factors. The GCF is x. Take another example. 3x squared plus 9x factor 3x squared and 9x. The prime factors of 3x squared are 3 times x, and the prime factors of 9x are 3 times x. Align the common factors. The GCF is 3x. Lastly, find the GCF of 4x squared plus 8x. Factor 4x squared and 8x. The prime factors of 4x squared are 2 times x, and the prime factors of 8x are 2 times x. Align the common factors. The GCF is 4x. Here are the steps to factor polynomials with common monomial factor. First, find the greatest common factor or the GCF of each term. Second, divide each term of the given expression with the GCF. Third, the factors of the given expression are the GCF and the quotient in step 2. For example, factor the expression 2x plus 6. First, get the GCF of 2x and 6. The prime factors of 2x are 2 times x, and the prime factors of 6 are 3 times 2. Align the common factors. The GCF is 2. Next, divide each terms of the expression to the GCF. So, 2x divided by 2 is x, plus 6 divided by 2 is 3. Therefore, the factors of 2x plus 6 are 2 times the quantity of x plus 3. Let's have another example. Factor the expression 14x cubed y minus 21y squared. First, get the GCF of 14x cubed y and 21y squared. The prime factors of 14x cubed y are 7 times 2 times x times x times x times y. And the prime factors of 21y squared are 3 times 7 times y times y. Align the common factors. The GCF is 7y. Next, divide each term of the expression to the GCF. So, 14x cubed y divided by 7y is 2x cubed, and negative 21y squared divided by 7y is negative 3y. Therefore, the factors of 14x cubed y minus 21y squared are 7y times the quantity of 2x cubed minus 3y. Next example. Factor the expression 9a squared b cubed plus 15a raised to 5b raised to 4 minus 18a cubed b squared. First, get the GCF of 9a squared b cubed, 15a raised to 5b raised to 4, and 18a cubed b squared. The prime factors of 9a squared b cubed are 3 times 3 times a times a times b times b times b. The prime factors of 15a raised to 5b raised to 4 are 5 times 3 times A times A times A times A times A times B times B times B times B. And the prime factors of 18A cubed B squared are 2 times 3 times 3 times A times A times A times B times B. Align the common factors. The GCF is 3A squared B squared. Next, divide each term of the expression to the GCF. So, 9A squared B cubed divided by 3A squared B squared is 3B. Plus 15A raised to 5B raised to 4 divided by 3A squared B squared is 5A cubed B squared. And negative 18A cubed B squared divided by 3A squared B squared is negative 6A. Therefore, the factors of 9A squared B cubed plus 15A raised to 5B raised to 4 minus 18A cubed B squared are 3A squared B squared times the quantity of 3B plus 5A cubed B squared minus 6A. The second kind of factoring that we will discuss today is factoring difference of two squares. Difference of two squares is just the reverse process in finding the product of the sum and difference of two terms. These are the things to remember in factoring difference of two squares. First, the expression should be a binomial. Second, the operation used should be subtraction. And third, each term should be a perfect square. Always remember that in factoring, always start with a common monomial factoring and then proceed to any other types of factoring. And in factoring difference of two squares, we will be using the principal root of the number, which means the positive root of the given number. Here are the steps to factor difference of two squares. First, solve for the square root of the first term and the second term. Then write the factors using this format. Quantity square root of first term minus square root of the second term times square root of the first term plus square root of the second term. Or, quantity square root of the first term plus square root of the second term times the quantity square root of the first term minus square root of the second term. Let's take another example. Factor the expression m squared minus 49. First, let us examine the expression. Is it a binomial? Check. Is the operation used subtraction? Check. Are the terms perfect squares? Check. Therefore, we can use factoring of difference of two squares. Before proceeding to factoring difference of two squares, check the expression first if it can be factored using the common monomial factoring. Since there are no common factors between the two terms, then we can proceed to the steps in factoring the difference of two squares. First, extract the square root of m squared and 49. The square root of m squared is m, and the square root of 49 is 7. Following the format, we could say that the factors are the quantity of m minus 7 times the quantity of m plus 7, or the quantity of m plus 7 times the quantity of m minus 7. Therefore, the factors of m squared minus 49 are the quantity of m minus 7 times the quantity of m plus 7, or the quantity of m plus 7 times the quantity of m minus 7. Next example. Factor the expression 9y squared minus 100. First, let us examine the expression. Is it a binomial? Check. Is the operation used subtraction? Check. Are the terms perfect squares? Check. Therefore, we can use factoring of difference of two squares. Before proceeding to factoring difference of two squares, check the expression first, if it can be factored using common monomial factoring. Since there are no common factors between the two terms, then we can proceed to the steps in factoring the difference of two squares. First, extract the square root of 9y squared and 100. The square root of 9y squared is 3y, and the square root of 100 is 10. Following the format, we could say that the factors quantity 3y minus 10 times the quantity 3y plus 10, or the quantity 3y plus 10 times the quantity 3y minus 10. Therefore, the factors of 9y squared minus 100 are the quantity of 3y minus 10 times the quantity of 3y plus 10, or the quantity of 3y plus 10 times the quantity of 3y minus 10. Lastly, factor the expression 12x squared minus 300. First, let us examine the expression. Is it a binomial? Check. Is the operation used subtraction? Check. Are the terms perfect squares? No. Therefore, we can't use factoring of difference of two squares. Try to factor the expression using common monomial factoring. First, solve for the GCF of 12x squared minus 300. The factors of 12x squared are 12 times x, and the factors of 300 are 25 times 12. The GCF is 12. Next, 12x squared divided by 12 is x squared, and negative 300 divided by 12 is 25. Therefore, the factors of 12x squared minus 300 are 12 times the quantity of x squared minus 25. Notice that the second factor is a binomial, whose operation used is subtraction, and the two terms are perfect squares, which indicates that we can still factor the second factor using difference of two squares. To factor x squared minus 25, first, extract the square root of the x squared and 25. The square root of x squared is x, and the square root of 25 is 5. Hence, the factors of x squared minus 25 are the quantity of x minus 5 times the quantity of x plus 5, or the quantity of x plus 5 times the quantity of x minus 5. Therefore, the factors of the expression 12x squared minus 300 is equal to 12 times the quantity of x minus 5 times the quantity of x plus 5, or 12 times the quantity of x plus 5 times the quantity of x minus 5. The third kind of factoring that we will discuss today is the sum and difference of two cubes. Let us review. The product of quantity x minus 2 and quantity x squared plus 2x plus 4 is equal to x squared times the quantity of x minus 2 plus 2x quantity x minus 2 plus 4 quantity x minus 2. After simplifying, we get x cubed minus 2x squared plus 2x squared minus 4x plus 4x minus 8. And then combining similar terms, we get x cubed minus 8. Notice that the product is a difference of two cubes. To get the factored form of the difference of two cubes, Reverse the process on the previous example. This is how to get the binomial factor. For the first term, get the cube root of the first term of the given expression. And for the second term, get the cube root of the second term of the given expression. Next, we will solve for the trinomial factor. First, square the first term of the binomial factor. For the second term, get the product of the first and the second terms of the binomial factor. And for the last term, simply square second term of the binomial factor. We will be using this format in factoring difference of two cubes. X cubed minus y cubed is equal to the quantity of x minus y times the quantity of x squared plus xy plus y squared. And in factoring the sum of two cubes, x cubed plus y cubed is equal to the quantity of x plus y times the quantity of x squared minus xy plus y squared. Let us take, for example, the product earlier. Factor x cubed minus 8. First, get the binomial factor. Extract the cube root of x cubed, which is x, and then get the cube root of 8, which is 2. The binomial factor is x minus 2. Next, solve for the trinomial factor. For the first term, square the first term of the binomial factor, x. The result is x squared. For the second term, get the product of the first and second terms of the binomial factor, x times 2. And the result is 2x. And for the third term, square the second term of the binomial factor, which is 2. The result is 4. The trinomial factor is x squared plus 2x plus 4. Therefore, the factors of x cubed minus 8 is the quantity of x minus 2 times the quantity of x squared plus 2x plus 4. Let's have another example. Factor y cubed minus 27. First, get the binomial factor. Extract the cube root of y cubed, which is y, and then get the cube root of 27, which is 3. The binomial factor is y minus 3. Next, solve for the trinomial factor. For the first term, square the first term of the binomial factor y. The result is y squared. For the second term, get the product of the first and second terms of the binomial factor y and 3. The result is 3y. And for the third term, square the second term of the binomial factor, which is 3. The result is 9. The trinomial factor is the quantity of y squared plus 3y plus 9. Therefore, the factors of y cubed minus 27 is the quantity of y minus 3 times the quantity of y squared plus 3y plus 9. Lastly, let's try to factor a cubed plus 64. First, get the binomial factor. Extract the cube root of a cubed, which is a, and then get the cube root of 64, which is 4. The binomial factor is a plus 4. Next, solve for the trinomial factor. For the first term, square the first term of the binomial factor a. The result is a squared. For the second term, get the product of the first and second terms of the binomial factor a and 4. The result is 4a. And for the third term, square the second term of the binomial factor, which is 4, and the result is 16. The trinomial factor is a squared minus 2a plus 16. Therefore, the factors of a cubed plus 64 is equal to the quantity of a plus 4 times the quantity of a squared minus 2a plus 16. Now that we are done with today's discussion, I would like to remind that you have to answer all your activities and exercises found in your module. This has been Teacher Russell saying every best decision in life requires someone to have a critical mind and a loving heart. Empower yourselves with mathematics because math matters.